Today, we're going to talk a little bit about time value of money. And we're going to dig into some basic concepts around dollars growing and dollars discounting and try to really develop an understanding of some basics in this space. First up, I really love this timeline. The idea being that there are really 5 elements to any time value of money problem. There's what we call present value. In other words, that's what you have today in an account or perhaps towards your future. It might be 0. But the idea there is that there's a starting point when we grow money. We have payments, and later on we'll dig into payments. And payments are the idea that we're adding to or taking money out of that present value, right? So over time, if it's a lottery, let's say we have $1 billion, we're going to take a little bit out each time. If it's a loan, like a student loan, we'll pay a little bit off each time, right? So the payments impact that present value, and that carries over the journey to future value, which is on the other side of this timeline. Future value is the end game. The future, where are we going to be? What goal have we met or not met? Have we paid the mortgage off? Have we paid the car loan off? That's future value. And there's 2 other variables too. We've got an interest rate that we apply to that present value. We apply to the payments, right? We may be a loan rate or some growth rate. And then we've got a number of periods. And periods might be in years, periods might be in months, periods might be in days if we want to get exciting about it. But that's all you've got with time value of money. And there's a real understanding. We can simplify it a little bit and just say, look, if I give you 4 of these, we can teach you how to solve the 5th. And that's where this gets exciting really fast. Now, we can use algebra to teach you to find the 5th, or we can use Excel. And the series of time value of money we're going to dig into, we'll show you some algebra, and then we'll show you some Excel to clear that up. But first up, if I want to find the future value of a single sum, that means I've invested money one time, no payments, right? So we're going to take payments out of this thing. So future value of a single sum, it's just algebraic. We take our present value times 1 plus our interest rate, and then we raise that to the number of periods. So if it's 5 years, we raise it to the 5th. If it's 10 years, we raise it to the 10th. But that gives us a compounding factor times our present value and gives us future value. You'll see that applied here in a moment. We can flip-a-roo, right? We can take present value of a single sum too, and it's the same equation as before, we just flipped a few things around. So if I want to find out how much do I need today to meet a goal in the future, that's what present value is. And algebraically, we can find that saying present value is equal to the future value tomorrow divided by 1 plus the interest rate, again raised to the n. So 5th, 6th, 7th, 10th, whatever power that is the number of years that go by. And those 2 relationships, future value and present value, set the stage for what's to come in our time value of money journey. Now, I like to show things in a little bit of a chart table setup, but the idea is if I give you 4, you can find the 5th, and we can use this, and we're going to use this as we learn together. Now, why do we need to learn time value of money, right? Like why is that exciting? Well, time value of money allows us to analyze opportunity cost. If you always have opportunity cost in your life, where you spend your time, the friends you hang out with, what holidays you go to with family, like all of that is the economic concept of opportunity cost. Is you only get one timeline to follow, and you can only invest your money, in so many ways. And so when we choose to look at time value of money and opportunity cost, we can say, well, I could put my money in the bank, I could buy Bitcoin, I could invest my money in a stock, I could buy land. And all of those are exclusive of one another. You get $1, you can pick one of those things. Time value of money helps us evaluate and make smart financial decisions by comparing things. What is the net present value of those 4 projects? What's the internal rate of return of those 4 projects? We use those skills to find that. The next real big concept in time value of money is this idea of interest, and really understanding interest on a level where we can work with. How much will you earn? Well, securities are volatile, right? We cannot guarantee the future of a stock or of a mutual fund or of crypto. We do not know what the future holds. We can look back at what it did before. We can look historically at average rates, but we can never really promise tomorrow. So interest is a little tricky because we always make assumptions in these things. We say, I invested in the S&P 500, which is a big stock market investment. Historically, it's earned between 9 and 13%. Doesn't mean it always will. Some years it goes down 20. So we use averages, but we try to use interest, and we try to use interest where we can compare projects at the same time. And so that's really goes back to opportunity cost. I'm going to teach you how to do that here in a minute. Then we've got the concept of compounding, moving things forward, and the concept of discounting. Compounding is actually pretty easy. You're just saying, well, what will I have in the future? What will something grow to? And then discounting is the flip. How much do I need today to meet a goal? How much do I need to save right now to meet that goal? These are the 4 key things we can do when we understand time value of money a little better. But opportunity cost in its most basic form, I give you a time machine, you go back to 1986, you have $1,986. Microsoft was an IPO in 1986, you could buy it on the New York Stock Exchange in 1986. Had you bought $1,000 of Microsoft in 1986, today it would be worth $1.3 million through the number of stock splits it's had and current valuation. On the other hand, if I give you money, $1,000, you go back in time, you put it in a savings account, on average, you would have earned about 3 or 4%, and you would have $3,000 today. Now, that's a pretty good story of opportunity cost, isn't it? In one case, you got 1.3 million. In the other case, 3,000. Same dollars invested, right? But you had to pick one path. So hopefully time value money can all help us invest in things like Microsoft, right? The next thing I wanted to dig into today is this idea of interest rates. And in order to compare projects, we have to be able to compare interest rates. So this gets into our first mathematical concept called an effective interest rate. How frequently interest compounds is somewhat meaningful. If I go to a bank and I buy a 1-year CD at that bank, well, I'm going to put $500 in. The bank's going to say, okay, Craig, if you leave it in all year, you get $50, 10%. Okay. So I take $500, it's in there a year, I get $550, we're done, right? That's an annual compounding rate. Once a year I get paid interest, and that's that. Very easy to understand. Things get a lot trickier as we get to quarterly, monthly, daily, and this concept called continuous compounding, right? That's where things get a little trickier to understand. The more frequently I compound an interest rate, the more interest I wind up paying or getting. And so we're going to see some examples here in a minute using these formulas to help us shape and show a little bit how we can all get interest rates on the same page so we can make those opportunity cost decisions. The idea, though, basically, is that if you have a rate that's compounding quarterly, instead of the bank paying you once a year, it pays you 4 times a year. And monthly would be 12 times a year, daily, every day. And continuous is just a mathematical construct that you would be earning interest instantly every second you had money in the account. And we use a logarithmic function for continuous. All right, so let's learn a little more about how to make interest the same. Let's say I give you this 3 opportunity cost problem. You can purchase one of the following. You have an option for a 5-year, $1,000 CD at a local bank, and you get interest once a year at 7%. So every year, you're going to get 7% interest on that CD. And when I say 5-year CD, that's the commitment you have to make. You have to leave it there for 5 years. So you'd get paid interest 1, 2, 3, 4, 5 times. Right? Let's compare that to another CD. I have a 5-year CD at a national bank. Now, this one's going to compound monthly, so you get 12 periods to compound instead of just that one. And then the last CD, we're going to do continual interest. Every second it's invested, you get a little interest. So which of these 3 would you pick? And it's really hard for us to do any analysis because all 3 are kind of in a different world, right? And let's look then at how we can use that effective interest skill so we can actually make opportunity cost comparisons. All right, local bank, pretty straightforward. How much will be in the CD at the end of 5 years? So let's take our future value formula and plug it in. You've got $1,000. That's your present value. 7 was the interest rate. 5 years of growth, plug it in. 1,000 times 1.07 raised to the 5th, boom. $1,402.50. That's what you'll have at the end of 5 years, okay? Now that's local bank, so we know 1402, that's the number to beat. Can we get there? Well, with our national bank, we can't compare apples to oranges. We have to find an effective rate, something that would be the equivalent of an annual compound. So how do we find an effective rate? Well, for a monthly compounding interest, which was this national bank CD, we would plug it in our formula. We would say 1 point, and we take 0.06 over 12, raise that to the 12th power. you wind up with 1.005, raise that to the 12th, you get 1.0616. And so we find that the monthly CD has an effective rate of 6.16%, right? Because it compounded monthly. So you earned interest on interest, just a little bit. Well, we know offhand that this won't beat the first one, but if we take 6.16%, we have 5 years of that growth, we wind up with 1345, not the winner, but we get a good idea. At least we could compare, right? We had an annual effective rate and an annual rate, right? At least we can make that comparison. The third CD is going to be continually compounding. And so we look at a logarithmic function, and it's called e, and you take the value of e, 2.71828, and then you just take that number, multiply it times the interest rate, and then we're going to take that and raise it. So at this point, what we have then, we're going to take 2.71828, we're going to raise that to the 1i power, so raise it to the 0.6, subtract 1, and you wind up then with 6.183%. And so in the end, continual compounding is going to give you a slightly higher number than the last one. So you're going to get 1349.80 contrasted with 1345.50. So in the end, what did we learn? We learned that 7% once a year beat 6% monthly and beat 6% compounding, but we also learned that the continual compounding beat the monthly compounding, right, by $4 or so. So the more it accrues, the better you are, but the lesson here for all of us is that we need to compare like-timed interest rates to get any sort of opportunity cost analysis. Well, that brings us to kind of the fun part of time value of money, and that's the idea of what do we use these skills for? Future value is always like, where am I headed, right? That compounding, where am I going? How much will I have at retirement? How much will I have when the kid starts college? We can also use compounding style problems for things like inflation. Well, today, a hamburger is $4. What will it be worth 20 years? What do I have to pay for a hamburger, right? We can use inflation for those. Discounting is more about what do I need today? What do I need to save today? How much do I need to put away today? Right? So if I want to pay for my kids' college in 18 years, what do I need to have today in that account to do it? And that's called discounting. So compounding, pay it forward, discounting, move it back. And we're going to pivot to Excel. I want to teach a little bit about just some basic Excel housekeeping that will make time value of money so much more fun. For those of you that would prefer to do it in Excel and not use the algebra, we're going to teach you that too. We can use Excel to take away a little bit from that algebra pressure of time value of money. But to do that well, there's some housekeeping I like to do when I'm in any Excel spreadsheet. The first is to delineate what cells you're going to enter data into and what cells are going to do the heavy lifting. So for this example, we're going to look at effective rate. If you remember opportunity costs, we have to align interest rates, right? So if we're comparing multiple projects, we need that annual effective rate instead of using whatever compounding rate. So just as an example, I went ahead and set up, okay, well, we've got a little effective rate calculator here. So I wrote effective rate in cell D1 on my example. And then in cell E2 and E3, I wrote nominal rate and compounding rate. So for nominal rate, we just want to make sure that our cell is set to a percentage, and 4 decimal places would be ideal. And then I've got this ability to compound rates, and I could compound rates 4 times a year quarterly. I could compound rates, monthly. I could compound rates weekly. I could compound rates daily, right? And so all of these options, once you have the little calculator built, you don't find yourself messing with the actual Excel function. If you want to learn the actual Excel function, it's equal effect, and then you just have that nominal and compounding, and it does all the heavy lifting for you. And that's really the basic time value of money modeling we'll do in Excel. The important element here is always have where you're going to key data in, and then always let Excel do the heavy lifting for you. Don't try to go in and edit little formulas each time you use it. Build yourself a nice template and use it over your journey. So that's really kind of Excel 101 in time value of money, and we'll get back to it a bit later.